Chat session. This is the chat session for MGF 1107 Liberal Arts Math 2 for Florida Southwestern State College. This video is to discuss, first of all, the topic apportionment methods for textbook section chapter 14 section 3. The standard divisor is found by dividing the total population under consideration by the number of items to be allocated. In situations dealing with allocating congressional seats to states based on their population, the standard divisor gives the number of people per seat in Congress on a national basis. The standard quota for a particular group is found by dividing that group's population by the standard divisor. In composing standard divisors and standard quotas, we will round to the nearest hundredth, that is, 2 decimal places. The apportionment problem is to determine a method for rounding standard quotas into whole numbers so that the sum of the numbers is the total number of items allocated. The lower quota is the standard quota rounded down to the nearest whole number. The upper quota is the standard quota rounded up to the nearest whole number. We will now discuss 4 apportionment methods. First one is Hamilton's method. Calculate each group's standard quota. Round each standard quota down to the nearest whole number, thereby finding the lower quota. Initially give to each group its lower quota. Give the surplus items one at a time to the groups with the largest decimal parts in their standard quota until there are no more surplus items. Quota rule. A group's apportionment should be either its upper quota or lower quota. An apportionment method that guarantees that this will always occur is said to satisfy the quota rule. Now we will discuss Jefferson's method. Find a modified divisor D such that when each group's modified quota, group's population divided by D, is rounded down to the nearest whole number. The modified quotients that are rounded down are called modified lower quotas. Apportion to each group its modified lower group. There is no formula for the modified divisor D. In Jefferson's method, a modified divisor is slightly less than the standard divisor. Adams's method. When using Adams's method, begin with a modified divisor that is slightly greater than the standard divisor. Find a modified divisor D such that when each group's modified quota, the group's population divided by D, is rounded up to the nearest whole number. The sum of the whole numbers is the number of items to be apportioned. The modified quotas that are rounded up are called modified upper quotas. Apportion to each group its modified upper quota. Jefferson's method gave New York 40 seats, which exceeded its standard quota of 38.59. This is called an upper quota violation. Webster's method. Find a modified divisor D such that when each group's modified quota, group's population divided by D, is rounded to the nearest whole number. The sum of the whole numbers for all the groups is the number of items to be apportioned. The modified quotas that are rounded are called modified rounded quotas. Apportion to each group its modified rounded quota. In many ways, Webster's method works in a manner that's similar to Jefferson's and Adams's methods. However, when using Webster's method, the modified divisor D can be less than, greater than, or equal to the standard divisor. Thus, it may take a bit longer to find a modified divisor that satisfies Webster's method. Now we will talk about Chapter 14, Section 4, the topic being flaws of apportionment methods. Alabama paradox. An increase in the total number of items to be apportioned results in the loss of an item for a group. First example of the Alabama paradox. After the 1880 census, two possible sizes for the House of Representatives were under consideration: 299 members or 300 members. The chief of clerk of the census office found that by having 300 members, the number of seats for Alabama would decrease from 8 seats to 7 seats. This was found using the Hamilton's method. Population paradox. Group A loses items to Group B, even though the population of Group A grew at a faster rate than that of Group B. In the early 1900s, Virginia was growing much faster than Maine, yet Virginia lost a seat to Maine in the House of Representatives. This is another example of a flaw in the Hamilton's method. New states paradox. The addition of a new group changes the apportionments of other groups. In 1907, when Oklahoma became a state, the House of Representatives had 386 seats. Based on its population, it was decided that Oklahoma should have 5 seats. But based on the Hamilton's method, the new total number of seats, 391, Maine gained a seat and New York lost a seat. The addition of Oklahoma with its fair share of seats forced New York to give a seat to Maine. Belinsky's and Young's theorem. There is no perfect apportionment method. Any apportionment that does not violate the quota rule must produce paradoxes, and any apportionment method that does not produce paradoxes must violate the quotient rule. Hamilton's method satisfies the quotient rule, but it can produce paradoxes. Jefferson's, Adams's, and Webster's methods can all violate the quota rule, but do not produce paradoxes. For many years, scholars of Congress tried to find a method that did not violate the quota rule and did not produce paradoxes. The previously mentioned theorem is stating this fact. This concludes the video for Chapter 14, Sections 3 and 4 for the MGF 1107 course. This has been Professor Marjorie Thrall-Muller of Florida Southwestern State College. If you have any questions, students, please don't hesitate to get in touch with me. Thank you.